Okay, hello everyone. I welcomes to all in our lecture series on solid state physics, that is your core paper 12, belongs to 5th semester B.sc syllabus. In this video or lecture we are going to discuss a important topic belongs to solid state physics, that is your reciprocal lattice. So let's start. Okay, the reciprocal lattice is itself a lattice. That means regular periodic arrangement of the points like this. Okay. So this figure, this regular periodic arrangement of the points, this is our end result of this discussion. Here these points are represents the planes. So before we are going to discuss the procedure how to draw the reciprocal lattice, first we are going to discuss about the basic idea about the planes. Already we have been discussed previously. Now just basic idea. Okay, here you can see this plane. If this is the origin, this is your z axis and this is your y axis. We have been considered, this is your x axis. So this plane will be 0 0 1. Miller indices of this plane will be 0 0 1, and this plane exactly half of the distance. So obviously this intercept of this plane will be how much? It will be y-axis and x-axis infinite, y-axis and x-axis infinite, and z-axis 1 by 2. If I am going to take the reciprocal, then it will be 0 0 2, right? Similarly, here you can see this is the plane having the Miller indices 0 1 1, and this plane having the Miller indices 0 2 2. Here the plane having the Miller indices 1 1 1, and here you can see another plane just backside of this plane. If this is your origin, then this plane's Miller indices will be 2 2 2. These things already we have been discussed in our previous classes in detail. Okay. Sorry. Now in our Bragg's reflection or diffraction topic, we have been discussed that whenever the X-ray will be incident on these planes, the X-ray will be diffracted along this direction. On the base of constructive interference, we are going to get the information of the planes. These things we discussed in our Bragg's law or Bragg's treatment class. Okay, so X-ray will be incident on the plane and diffracted on the base of constructive interference. The intensity will be maximum and the planes will be identified, right? Here in this unit cell, not only 001 002 plane will be possible, but also these two planes will be possible, these two planes also possible, many planes can be constructed. Okay, now problem is that due to different orientations, see this is the one orientation, this plane have one orientation, this pink color plane have another orientation or slope. Due to different orientations or slope of crystallographic planes, it becomes difficult to visualize all such of planes at a time. So at a time, if we are going to analyze or visualize all the planes, then it is somewhat difficult. Okay, to simplify this problem, P.P. Ewald he is a German crystallographer, developed a new type of lattice which is called the reciprocal lattice. So this problem was simplified by P.B. Ewald, who is a German, who was the German crystallographer, by developing a new type of lattice known as reciprocal lattice. Now we are going to go for the procedure to draw the reciprocal lattice. So these are the three basic steps or procedures we have to follow to draw the reciprocal lattice, which is given by P.P. Ewald. So the first step or procedure is written that draw the normals to all set of planes from a common origin. So before we are going to draw the normals, first we have to take some idea about all sets of planes. What is the set of planes? First we're going to take some idea or knowledge, simple knowledge regarding set of planes. Okay, so here you can see this is the uh, cube, and if this is your origin, then this plane will be called as 0, 0, 1 plane, or the Miller indices of this plane is your 0, 0, 1. Now if I am going to shift the origin from here to here, then this plane will be called as your 0, 0, 1 plane. Here these two planes are called as your set of planes. Okay. Now we are going to consider other set of planes. This set of plane already we have been discussed. Consider this set of plane. Here you can see that 0, 0, 0, 1, 1 plane, suppose at origin. If I am going to shift the origin, then this will be called as your also 0, 1, 1 plane. See, this is your 0, 1, 1 plane. If I will shift the origin, then 0, 1, 1 plane will be passed through the origin. No problem. Okay. Likewise, here you can see this is your 0, 2, 2 plane. So if I am going to change or shift the origin, this will be also called as 0, 2, 2 plane, or this plane will be passed through the origin, also called as 0, 0, 0, 2, 2 plane, or having 0, 2, 2 Miller indices. Okay. Now we are going to draw the normals to all set of planes like this. Normal drawn this set of plane, again normal drawn on this set of plane, normal drawn on this set of plane. The length of the normal, here we drawn the normal, but how much length we are going to be consider on this normal, this is the step 2 we have to follow. The length of the normal will be the reciprocal of interplanar spacing of the corresponding set of planes. So the length on the normal, we are going to consider how much distance? Reciprocal of the interplanar spacing of the corresponding set of planes. So this is the set of planes. So this is nothing but called as your interplanar spacing, that is your D001. Its reciprocal, if we are going to consider, then obviously this length will be less than this length, 1 by D001. Suppose this length is this much. So from origin up to this much, we have to move on the normal, and we are going to put a point, and this point is called as your reciprocal lattice of this plane. So for the example, you just consider that this length is your 3. For the example, you just consider this interplanar spacing is your 3. So this distance will be how much? This distance will be 1 by 3, right? Okay. Now we are going to consider this distance. This distance obviously less than that D001. The interplanar spacing between 0, 1, 1 plane or 0, 1, 1 set of planes, this interplanar spacing is this one, D0, 1, 1 is lesser than this D001. So obviously if we are going to consider reciprocal of this one, obviously greater than that of this reciprocal. So this reciprocal value, if we are going to consider this value is 3, so this value is 0.3. So if we are going to consider this space is your 2, suppose 2, then its reciprocal will be 0.5, which is greater than that of the 0.3. So the reciprocal of D011 will be this much length, that is your larger than this length, we can consider, and we found by considering one example. Okay. So from here, this origin up to this much, we have to move on the normal, and we are going to put the point. This point is called as your reciprocal lattice of this plane. Likewise, if we are going to consider 0, 2, 2, then the interplanar spacing between set of plane of 0, 2, 2 is this much, which is lesser than as compared with this. So obviously it's 1 by D022 or reciprocal will be larger than this length. Okay, so larger than this length means up to this much length, here it is there. So this length will be larger than this length. So this length, that means from center up to this much on the normal we have to move, and here we have to put a point, and this point is called as your reciprocal lattice of this plane. Collectively, if we are going to consider all the planes and their corresponding lattice, reciprocal lattice points, then for 001, this is the lattice point. For 011 plane, that means for this one 011 plane, this is the lattice point. For 022, this is the lattice point. Likewise, several planes we can consider in the Q, and we can found its corresponding lattice points. These lattice points will be called as your reciprocal lattice. Okay. You can see that at the end of our discussion in this video, you can see this type of lattice points we can found, or we can found the so-called the reciprocal lattice of their corresponding planes. So here these points represent the planes. Okay. For that, we consider a monoclinic crystal structure in which C is larger, C vector or along Z axis intercept you can say is larger than Y axis and X axis. So C magnitude greater than B and greater than A, and we know that the angle between the two angles will be 90 degree and beta is greater than 90 degree. That means this is the beta. Angle between Z and Y axis is your beta, and this is X and Y is called as the alpha, and X and Z is called as the gamma. Already we have been discussed. So this angle is greater than the 90, and these two angles are 90 degrees. So this is the monoclinic crystal structure we consider to find out or to draw the reciprocal lattice. Okay. So here set of planes we are going to be consider. This is the set of planes belongs having the Miller indices 001, 001. Okay, and this is the set of plane having the Miller indices 010. Here you can see Y axis has the intercept and there is no Z axis and X axis intercept. So obviously these two planes having the Miller indices will be 0, 1, 0. See, if I am going to shift the origin over here, so if I will shift the origin towards this side, then this will be called as 0, 1, 0. Already we discussed in our previous slide how if we are going to shift the origin, then this is 0, 0, 0, 1. If I will shift the origin to downward, then this will be also called as 0, 0, 1. So these two planes are called as the set of planes. Okay, these two planes are called as set of planes, and this plane cuts the Z axis at here and Y axis here. X axis, with X axis it is parallel, so its Miller indices will be 0, 1, 1, right? 0, 1, 1 plane. Now if we are going to consider this plane, it cuts the Z axis at half, okay, at middle of the Z intercept. So its Miller indices will be 0, 1, 2. Okay, that we know. How it is? X axis intercept is infinite and Y axis is 1. Z axis is your 1 by 2. So take the reciprocal, this will be 0 and this is 1 and this is 2. So 0, 1, 2 will be the Miller indices of this blue color plane, right? Now we are going to consider only one plane. We are not going to be consider the set of planes. One plane we are going to consider this plane and this plane. This is your 0, 1, 1, 0, 0, 1. This is your 0, 1, 0, 0, 1, 1 and 0, 1, 2. Now, according to the procedure, we have to draw the normals to all set of planes from the common origin. Okay, so this is your origin. From this origin, we have to draw the normals to all set of planes. So here the planes are this one 001, 010, then 011, then 012. We have to draw the planes to all the normals, draw the normals to all the planes like this. Here this is the normal, that is your OA normal on 001 plane. Now OB normal drawn on this 010 plane. Then OC normal drawn on 011 plane, and OB normal drawn on this 012 plane. Okay, see here red color normal is perpendicular red color plane, and here green color is perpendicular green color plane, and here pink color is perpendicular pink plane. Like this you just consider. Here you can see this is the perpendicular, this is the perpendicular green color, and this one is perpendicular to this plane. Okay, now for simplicity, the planes are represented in 2D form. So here the planes are represented in 3D form. Now for the simplicity to draw the reciprocal lattice, we consider the planes in 2D form. How it is? Carefully you have to watch. Here by removing this plane in 3D form, I consider this plane here one line O P1 red line I consider, which represents the 001 plane in 2D format. Okay, initially it was like this. Initially it was a plane, but for simplicity to draw the reciprocal lattice, I remove that plane and I drawn a red line OP, which represents the 001 plane, right? Likewise, we remove this plane, this pink color plane, and we drawn a line OQ, which represents the 010 plane. Okay. Likewise, we remove this green color plane and we consider a line, that is your PQ, which represents the 011 plane. Likewise, we remove this plane, this blue color plane, this one, and we drawn a this line PR, which represents the 012 plane. So here for our simplicity, the 3D structure of the plane converted to 2D structure. Okay, this red line represents 011, this one pink one 010, this green one represents 011, and this one blue line 012 plane. Okay, all the Miller indices I written nearby corresponding planes. Okay, now to draw the reciprocal lattice, or to mark the points along OB, this is your O. Okay, this is your O. Here I am going to so to mark the reciprocal lattice points on these normal, see this is the OB is the normal on this plane 010, and this OA is the normal on 001 plane, that is your OP plane. So to mark the reciprocal lattice points on these normals, we considered here one example. Example means already we consider the monoclinic crystal structure, but the value of C, B and A we considered like this. As C greater than B greater than A, here we consider C value is your 3 or 3 centimeter, you can see. You can say B value is 2 centimeter and A value is your 1 centimeter. Too easy to understand, too easy to locate the reciprocal lattice. We consider this example. The length value of A, B and C are this one 1, 2, 3. Okay. Now we are going to calculate the interplanar spacing, then its reciprocal, then we are going to find out the value. From the value we can easily locate the reciprocal lattice on these planes. Okay. Here you can see that we considered only this plane 0, 0, 1 plane, and its corresponding normal is this one. This one is the corresponding normal. Here the normal is your OA, and this is the red line, and this is also a red line, dotted line, OA. Okay. Now first we have to consider the interplanar spacing of the set of planes of 0, 0, 1. So we know that the interplanar spacing for in general the interplanar spacing is this one, DHKL. These are the Miller indices. DHKL is your 1 by H square by A square, K square by B square, L square by C square to the power 1 by 2, or you can say root over. Okay. So as per the example, we consider the A value is 1, B value 2, 3, C value is your 3. Now we are going to put the values for this particular plane. For this particular plane, this one 0, 0, 1 plane. Okay. For 0, 0, 1 plane means for this plane this is the normal. First we have to find out what is the interplanar spacing of the set of plane of 0, 0, 1. So you just consider this formula, 1 by, here H and K are 0, 0. So 0, 0 plus 1 square. See, L square by C square. So L is your 1. C we considered as 3. So 1 square by 3 square root over, and we are going to find the D value is equal to 3. Okay. D, that means interplanar spacing of set of plane of 0, 0, 1. Set of plane means this is the cube, and we already discussed that this is your y axis, x axis, and this is your z axis. This is the set of planes. This is your 0, 0, 1 and this is your 0, 0, 1. So this interplanar spacing here we found how much? 3, and its reciprocal is how much? 0.33. So let the 0.33 distance from this origin to this point. This is the reciprocal of the interplanar spacing is this much. So here we are going to put a point. This point is represents what? This point represents the plane, set of plane having the Miller indices 0, 0, 1. This is not the simple point. This is the point in the reciprocal space. In the reciprocal space, this point represents the set of plane 0, 0, 1. Right? Now we are going to consider for 0, 0, 2 planes. 0, 0, 2 planes means where it will be there. See, here you can see that if this is the set of planes belongs to 0, 0, 1, then at the middle this will be called as your 0, 0, 2. If I am going to shift the origin, then this will be also called as 0, 0, 2. Okay, so this distance will be called as D002. Now we are going to first calculate this D002 by considering this example. Okay, so here D002 will be how much? 1 by h value 0, k value 0, l value is here 2. 2 square by 3 square root over. We found that 3 by 2. So here 3 by 2 value is your interplanar spacing between the set of plane of 002. Okay. Now its reciprocal will be 1 by D002 will be how much? We found that 0.66, just double of this value. So from this origin, if this point is located at the distance 0.33, then 002 plane will be located at the distance how much? 0.66. 0.66. Likewise, suppose we are going to consider 003 plane, then it will be located at the distance from the origin. How much distance? Here 0.33, 0.66. This distance will be 0.99. So likewise, we are going to get the lattice points of the set of planes. So this lattice point is belongs to set of planes 001. This lattice point is the lattice point belongs to 002. This is 003, set of planes 003. Likewise, we are going to put the points, so called lattice points, in the reciprocal lattice, Okay. Now we are going to consider for this plane 0 1 0. Here you can see 0 1 0. 0 1 0 means this plane. Okay, for this plane 0 1 0 plane. Okay, for 0 1 0 plane we drawn the normal along this side. Okay, that is your OB. Okay, OB. This is B. OB. Okay, OB. So now this is your OB normal, which is drawn on this plane, having the Miller indices 0 1 0. Now we are going to find out interplanar spacing, then its reciprocal. So 0 1 0 reciprocal, D010, if we are going to calculate by considering this example, then this will be 0 by 1 square, 1 by 2 square, 0 by 3 square. We are going to get 2. And its reciprocal we are going to find out 0.5. Here you can see that for 0 1 0 this is 0.5. For 001 this is 0.3. Okay. That means this is larger, somewhat larger distance as compared to this one. Okay. Here we considered one example. Okay. From this example we found D001, reciprocal of D001, the distance if 0.33, and we consider this much distance, then 0.5 obviously will be greater than this much distance. That means here you can see this distance is this is your 0.33, so 0.55 will be larger than this distance. So we located, so here I have been located the 010 point here. So this point is represents the plane or the set of plane 010, right? Now similarly we can consider 0 0 2 0 plane. Here you can see this is your 0 1 0 plane, right? This is the z axis, and this is your y axis. We consider this is x axis, z axis we consider. So this is your what? This is your 0. Sorry, this is your this plane. This plane is your this plane. See, here you can see this plane. This plane is your 0 1 0. This plane is 0 1 0. Okay. And we can, if we are going to shift the origin, then this plane just middle of here, middle of this line, and this will be called as your what? 0 2 0 plane. If I am going to shift the origin, this will be called as 0 to 0 plane. Now for this plane, where will be the lattice point we are going to be located? Here you can see for 0 to 0, we found the interplanar spacing is your 1. If we are going to consider this example, the interplanar spacing we found 1, and reciprocal of this interplanar spacing 1 by 1 itself 1. That means it's just double of this length, 0.5 then 1. So from the origin, if this distance is your, if from origin to this distance is your 0.5, then just double length we are going to get 0 to 0 plane, or the point we have to locate. From the origin, from here to here, the distance is 1. So this point is represents this point. This point is represents the plane, set of plane 0 to 0. So here, with the help of this example, we located the 001, 002. Similarly, this will be 003, and this is your 010, 020. Similarly, here same distance, here 0.5, 1, then at 1.5 distance. At 1.5 distance, suppose here it will be elongated like this. Here this will be 030 point. Okay. Likewise, 040, 050, 004 along this side, 004, 005 we can get. Now we are going to draw these lattice points in our main figure. This one is your main figure, right? This one is your main figure. So here 001 plane, the corresponding reciprocal lattice point will be here. For 002 will be here like this. So for 001 and corresponding 002, 003, these are the lattice points will be located on this normal. Okay, so this point will be 001, this point will be 002, 003, 004. Remember that these points are in the reciprocal lattice, and these points represents the planes, set of planes. Similarly, along this OB, we are going to locate the 010, 020, 030 and 040 planes, or the lattice points which are represents the corresponding set of planes. Okay, now we are going to draw the lines which will be easy for us to represent the other lattice points. Okay, now we are going to consider this plane, this 011 plane, this one, this blue color plane 011. So obviously this will be 022. Now we are going to find out what will be the length we are going to consider for 011 to locate the reciprocal lattice. Here you can see for D011 the value will be 1.6, and the reciprocal of 1 by considering this formula, okay, by considering this formula, here D011 will be this much. So you just calculate, it will be 1.6. Okay, reciprocal of 1 D011, 1 by D011 will be 1 by 1.6 is your 0.6. So from this origin, at the distance 0.6, we have to locate the point which represents the 001 plane. This point represents the 011 plane, this plane. This point represents this plane. Now we are going to consider this plane, 022 plane. If we are going to consider 022 plane, then what will the value? D022, if we are going to calculate, the value will be 0.8. So reciprocal of 0.8 will be 1.2, just double of this value. Hence, at the distance 1.2, we are going to locate the point that is your 022. So this point is nothing but representation of this plane, in the reciprocal reciprocal space. So this entire space is called the reciprocal space. This is called the reciprocal lattice, and this lattice point represents the corresponding set of planes. Okay. Next, for 033 plane will be found at 1.8. See, previously we found the double length of this one is this one, then triple length of this one is this one. Okay, so for 011 the length is 0.6, for 022 the length is 1.2. Likewise for 022, for 033 the length will be 1.8. Okay, if you are going to calculate, then you are going to find out the 1.8. That means from this origin at 1.8 length we are going to be put the lattice point or the reciprocal lattice point as 033. So here this 033 point represents the set of plane belongs to 033. Okay, now we are going to locate these points in our main figure. So here you can see we are trying to find out, or we are trying to locate these points for this plane 0, 1, 1, 0, 2, 2. So here you can see this is your 0, 1, 1, and below this 0, 1, 1, 0, 2, 2 will be there, whatever here we have been discussed. So for 0, 1, 1 the point will be here. Okay, the point will be here, that is your 0, 1, 1 point, this one. Likewise 0, 2, 2 will be here. Already we have been discussed here 0, 2, 2 at the distance 1.2, that means just double. So here you can see if from origin to this point is your 0, 1, 1, then double of this length, double of this length we can found the point, the location of the 0, 2, 2 plane. So this point is represents the 0, 2, 2 set of planes. This point represents 0, 3, 3. Likewise this point will be represents 0, 4, 4 set of planes. Now we are going to go for the next plane, that is your 0, 1, 2. So here we are going to calculate traditionally. This is your 0, 1, 2 plane, and obviously this will be half of this length, so this will be 0, 2, 4 plane. Miller indices of this plane is 0, 2, 4. This is your 0, 1, 2. Now first we are going to find out the interplanar spacing of this plane D012. For D012, considering this formula, you can found the interplanar spacing of D012 will be 1.2. The reciprocal of D012 we found 0.8. So here we can found a 0.8, the reciprocal of D012. Okay, now if this distance from this origin up to this much is your 0.8, then here we have to locate the point which represent the set of plane of 0, 1, 2. Right, now we are going to go for this plane 0, 2, 4. You just calculate. The interplanar spacing will be 0.6 and the reciprocal will be 1.6, just double of this one. So the distance from the origin up to this much, if it is 1.6, then here we are going to locate the point in the reciprocal space, which will be called as your 0, 2, 4, and this point is nothing but a reciprocal lattice point which represents the set of plane 0, 2, 4. Right, okay. Now these points similarly we can found here at 0.8, 1.6, then 1.6, 0.8. That means 4 2.4 at the distance 2.4. If this distance is 2.4, then this point will be called as your 048. Okay. Okay. Now we are going to locate these points in our main figure. So this is the main figure. So this point will be nothing but your 0 1 2. So this point is your 0 1 2. This point will be 0 2 4, and if it will elongate up to, if I'm going to extend the OD, then we are going to find out 0 4 8 at its corresponding distance. So here we located some of the lattice points which represents the corresponding set of planes. Now this point will be represents which plane? Here you can see from here to here this is your 0 2 0. From here to here this is your 0 1 2. So obviously this point will be how much? 0 2 1. Okay, 0 to 1 plane. So this point will be 0 to 1, right? 0 to 1, and this point will be 0 3 1. This point will be 0 4 1. That means here 0 3 1 represents the lattice point, which represents this lattice point represent the set of planes having the Miller indices 0 3 1. Okay. Likewise, this point will be, the value will be 0 3 2, 0 3 2. This will be 0 4 2, right? Okay, 0 3 2, 0 4 2. So this 0 3 2 means this point represent the set of planes 0 3 2 in direct lattice. Okay, so 0 3 2, a plane in your direct lattice, only a point in your reciprocal lattice. Okay, so this is the plane 0 3 2 is your plane in your direct lattice. This is the point in this reciprocal space. This space is your called as reciprocal space, or sometimes it is called as K space. Okay, for different applications. Okay, so here this point will be, what will be, it will be 0 4 3, right? 0 4 3, and likewise this point will be 0 2 is there here, 0 0 0 3. So 0 2 3. So this point will be 0 2 3. This point will be 0 3 4, and likewise these 2 points will be here, this point 0 1 3. This is your 0 1 0 0 0 3 0 1 3. This will be 0 1 4. So here we located almost all planes as points. So here you can see these points are repeated, a periodic repetition along this, along this, along this, along this, and along this. So repetition, periodic repetition means we can say this is called the lattice. So this lattice, repetition of the points is called the lattice, and this lattice we found by considering the planes in the direct lattice and drawing the normal, blah blah, whatever we discussed, followed the procedure, and we found this lattice, and this is called as your reciprocal lattice. Reciprocal lattice of the monoclinic crystal structure. Okay, of the monoclinic crystal structure. This is called the reciprocal lattice in the reciprocal space, right? Okay, now so finally we found this one. Okay, so here this reciprocal lattice drawn by considering the monoclinic crystal structure. So here I suggest to all of you that follow the same procedure, draw by yourself reciprocal lattice of cubic lattice, draw the reciprocal lattice of the tetragonal crystal, cubic crystal and tetragonal crystal. So here one thing I forgot to share with you, you can see that reciprocal lattice of monoclinic itself a monoclinic. So here you can see this distance is not equal to this distance. Obviously you can, if we are going to consider the x-axis distance, it will be also different. So monoclinic crystal structure uh, and its corresponding reciprocal lattice itself a monoclinic crystal structure. So here this is the in the form of points. So this can be transformed to direct lattice. This can transform to reciprocal lattice by using Fourier transform. Okay, because we know that the Fourier transform is the mathematical tool which transform one space to another space, frequency domain to time domain to frequency domain. So reciprocal lattice, if we are going to consider it is in the frequency domain, then the direct lattice is in the time domain. So uh, direct lattice direct lattice is in your time domain. Okay, so time domain to frequency domain and frequency domain to time domain, frequently we can change or we can transform by using Fourier transform, that we know. Okay, so this is the reciprocal lattice of the monoclinic crystal structure. So I suggest to all of you that you just draw the reciprocal lattice of cubic crystal and draw the reciprocal lattice of tetragonal crystal. Okay, you draw by yourself. Okay, and download the link given in the description. You just download whatever we discussed in this video, the proper note for the B.sc exam, B.sc honors exam. I prepared the note for you. You can download from the link which is given in the description. Okay, so thank you so much for watching this video. Thank you.